Hi, I am Sonia. Today I am presenting the topic embedded system for indoor air quality monitoring. These are the topics we are covering here. In the next slide, introduction. Indoor air quality is a critical aspect of our daily lives, impacting our health and well-being. Addresses this. Our project focus on developing an embedded system specially designed for monitoring indoor air quality. The system aims to provide real-time data and analysis to help users make informed decisions about their indoor environments. We are creating something to make sure the air we breathe inside buildings is clean and healthy. We will do this by using sensors that keep an eye on the air quality and sends that information our system. The systems the looks at the data and tell us in real time if the air is good or bad, if there is any problem is there. In coming to the next slide, here the infrastructure uh, of our embedded compares various hardware and software components working parallelly together. This includes sensor for measuring air quality parameters such as temperature, humidity, carbon dioxide, and volatile organic compounds. These sensors are connected to a microcontroller unit that processes the data and communicates with the central processing unit for future analysis and displaying hardware and software components here. Coming to the next slide, starting with initializing with components and establishing communications, it then collects real-time air quality data through sensors processes it to identify trends and anomalies and makes the decision according. If any issues arise, it generates alerts or uses the present analyzer data through an invite interface, use easy understanding and interactions. Our systems would like a assistant starting with initializing its components and establishing communications. Then it collects a real-time air quality data through sensors process to identify trends and anomalies and makes decision according. If any issues arise, it generates alerts for users and the presence analyzed data through an initiative interface for easy understanding and interaction. These are the behavior analysis. And coming to the next slide, sequence diagram for designing an embedded system for indoor air quality monitoring. The slide shows that understanding how our embedded system behaves in different sensors is crucial for optimizing this performance. By analyzing its behavior, we can identify patterns, trends, anomalies in air quality data. The allows implement adaptive algorithms and control strategies to ensure optimal indoor air quality conditions. Step by step, the process of our system works. First, it starts up and gets ready to work. Then it collects data from the sensor to about the air quality. Next, it collect the data and understanding what's going on with the air. If there is a problem, it alerts us, and finally we can see all this information and interact with them system. Coming to the architecture overview, here we are getting a closer look at everything is connected. We have a sensor that pick up the changes, the environment microcontroller that likes the brain of the operation, and communication tools that let your system talk to device. And here they are analyzing, then visualization, then it's giving to the user. Coming to the next slide, these are the functional requirements: sensing and monitoring, data processing. Here the functional requirements: the system needs to be able to do, it needs to accurately measure things like CO2, VOCs, and particulate matter in real time. It also needs to process the data quickly and make decisions if something is wrong. it is able to communicate this information to us. Coming to the next slide, non-functional requirements. These are the other important things of our system needs to do. It needs to work fast and rapidly, no matter where it is installed. It has to keep us safe by not giving as wrong information, as it has to keep our data secure and private. Also, it needs to through enough to handle different environments and external factors. And coming to the next slide, operation environment. Our embedded system is designed to operate in various indoor environments, including homes, offices, schools, and healthcare facilities. It is capable of adapting to different configurations like external factors and considerations. Coming to the next slide, analysis of computer and behavior components and behavior. Here, sensors, microcontrollers, and data processing unit. Here all the different parts of our system, we have sensors that measures the air, a microcontroller that does the things, and a bunch of other stuff like displays, communication tools, and way to store data. Coming to the next slide, here the data storage and logging, alerting mechanisms, and power management systems, user interface and fault detection. In coming to the conclusion, we are saying that we are doing the big deal because it is about keeping people healthy indoors. We talk about ways we can make it even better in the future, like adding more advanced technology, and we are point out some places you can go if you want to learn more about this stuff. Future development could include IoT integrations and enhance connectivity and artificial intelligence like machine learning for predictive analysis, for air quality management. And coming to the next slide, these are the differences we have taken from IEEE papers. Thank you.